Hi, I'm Ming Ching. Today, let's take a look at a very interesting problem, the lowest common ancestor in binary search tree. So first, what is lowest common ancestor? Imagine we have a binary search tree like this. Given any two nodes, P and Q, this node will be their lowest common ancestor because it's the ancestor of both P and Q, and it's the lowest one we can find. Another way to think about it is to think about the root to P path, which is this path, and the root to Q path is this path. These two passes overlap at two nodes here, and we want to return the lowest one. As you can see, the lowest common ancestor is always the diverging point of these two passes. In order to find it, let's first think about another question. If I give you P and Q, and give you any single node n, can you test if n is the lowest common ancestor of P and Q? Remember, in the binary search tree, every node is associated with a value, so that we can compare the value of the three nodes and draw a chart like this. First, P is less than n, P is greater than n, Q is less than n, Q is greater than n. In this case, P and Q are all less than n, so that we know P and Q are in the left subtree of n. Then n is not the lowest common ancestor of P and Q. Why? Because we can find another node in the subtree to be their ancestor. Similarly, n is also not the answer that we want to find. But in this case, Q is less than n, P is greater than n. Then we can tell n is the answer. Why? Because Q and P is separated into two childs of n. If we take the root to P path and the root to Q path, they must pass through the node n and diverge from there. Similarly, n is also the answer in this scenario. So how to write a pseudocode for this problem? Let's write a function called LCA, passing the node n, Q, and P. We will return the lowest common ancestor of P and Q within the tree rooted at n. So, and then in this function, we divide to different scenarios. Let's say this is case 1. If it's case 1, we need to continue our search in the left subtree of n. So let's return LCA in left subtree, and then give it the same Q and P. If it's scenario 2, continue our search in the right subtree. Else, it's in these two scenarios, we directly return our answer. And don't forget to consider corner cases. For example, if n is null, which means the tree is empty. In this case, I think we should return null. And another case, what if n is either P or Q? This means P is not there, for example, here. And P is directly the ancestor of Q. And of course, P is the ancestor of itself. Then the answer will be this node. We return n. And this is the answer. Thanks for watching.